Thank you so much. All right, let's go ahead and get started on this. So just a heads up, if we have some spare time, we might do Q&A. If not, you can find me on most of the internet as well as physically here. I'll also be doing a workshop tomorrow. So let's get into columnar storage, redefining data management for the modern era. So pretty much what we're going to go over is the feature and highlights of columnar databases. What is Apache Arrow and Apache Parquet and how do they relate, basically? Leveraging tools for data analytics and customer use cases using columnar databases. So quick note here, I work for ClickHouse DB as of roughly, this is my 8th day on the job, so I'm in my first 2 weeks. Before that, though, I worked for InfluxDB, which was also a columnar database. So basically, I've just switched to a different DB. The use cases that we're going to go over are just going to be ClickHouse's customers. It's just easiest to reference them. There are many, many customers, many companies in general that use columnar databases. So quick questions here, and I can kind of see everyone even in the dark. So who here is pretty familiar with databases? Like you've used them or learned about them outside of school in particular? Okay, good. How many here are familiar with columnar databases? A little less hands. That's totally fine. That's totally fine. That's why we're here. So some features and highlights. So first things first, and one thing to note with databases is they don't really follow any per se rules anymore. For example, you have something like relational, which we tend to call SQL databases, which SQL is a query language. It is not an actual database structure. We just tend to say like PostgreSQL or MySQL Server. SQL is a query language. There are plenty of what we consider NoSQL databases to use the SQL query language, or at least a flavor of it. But basically, you've got your relational, you've got your Postgres, your MySQL, the most basic underlying databases that power like 70% of databases are relational databases. They deal with orders, customer records. They are transactional, as we tend to call them. They basically say, I want the user information for Terry. And Terry lives in this row, and this is all of his user information. That is the kind of very good things that relational databases are very good at doing, is those transactional record keeping. They are fantastic at it. Like I said, they are the bedrock to an extent of all databases and all companies. Then you have your NoSQL DBs. So this comes in so many flavors, but I tend to look at this as like a MongoDB, like a document database. There are more generalized NoSQL DBs. And by that, I mean, if you go on Mongo's DB website, you will see that they can do everything. That's what I mean by generalized. Some databases do not claim to do everything underneath the sun, but Mongo, for example, will say that they can do pretty much everything because they're a document store. They're really great for things that are like high throughput, and these tend to be data sets that you need to manipulate a lot more. We tend to say that this is data sets where you need to be able to drop a lot of data or add a lot of data that's very specific to aggregation. So this is in particular things like if you've ever been on Amazon, this would be very specific to each item. For example, Amazon sells things like a desk. They also sell something like a plant. These have two very different descriptions. They have very different details about them. That would be great in a NoSQL database where when in the future you no longer sell desk, you can just delete the desk object. And vice versa, you can manipulate the plant object to have information like where it comes from or details about how much berries it will produce, etc. Then you have your search databases. So these are things like Elastic, but basically the big thing here is they are good for distributed searching. Again, if you've ever done something on Amazon where you filter based off price or if it's got Prime or not, that's using a search database on the backside normally. Same with, in general, Google. Google is just a giant search engine. It's got a search database underneath, under the hood, powering it. They're also good for things like logging in particular. And then you have columnar databases. And again, these can be SQL-based. They can be NoSQL-based technically because they're columnar, but they tend to focus on things like analytic use cases. They tend to go beyond just logging. They tend to do also things like events and traces, basically open telemetry data, and aggregations. So for example, here is a very small version of what a row-oriented DB would be holding. You've got some IDs here. That would be like your primary index. You have a description. For this, we have some cell phones, some information, a Boolean if they're unlocked or not, and then the price. Pretty straightforward. This is also a typical query for what we would call a relational database, but again, just a SQL query that says, I want to know the price of the phone where the ID is 102. This is pretty normal, pretty standard. It's just like what I said earlier, we're looking for information on a specific person. Same thing, we're looking for one phone, one row, it's transactional. A column-oriented table flips this around a little. You have an ID, but that's how it's all grouped together. So you have all your IDs together, you have all your descriptions together, and in particular on this set, we're also very keenly interested on all the pricing information being together. Because what that allows us to do is something like select the average price from all of the phones. Now again, this is a very small data set. We've only got 4 things here. But if you could extrapolate this out and just imagine if we had 4 million of these that we need to get an average for, it is not computationally efficient to pull the phone price from every single row. It takes forever. It's not really what, again, if you were to try to do this on something like Postgres, like especially plain Postgres, not like one of the many versions of it that might have a little bit more aggregation or analytical workloads, this is not going to go well. It's going to take forever, again, at scale. With 4 rows, it's going to be great. At 4 million rows, it's not going to be having a great time because it has to call for each one of those 4 million rows, get the phone price, and then you're also assuming that it has something like average available in the SQL language because, again, a lot of these columnar DBs, even ones that use SQL, have like an analytical workload, basically. They're using a flavor of SQL that allows them to do things like statistical averages and just in general more analytic queries. So, for example, here are some examples of columnar databases. And by the way, there's like 30 of them. I just couldn't fit all of them onto a slide. These are some of the big ones. Apache Cassandra also lives in a special case where it's technically a column family, but it's basically it's older. That's the nice way to put it. It's an older DB that was invented before we had some of the more modern columnar data stores. So it's a little special here, but basically it is a NoSQL. It's a true NoSQL in that like it does not do the query SQL language. That's totally fine for it. But then all these other ones have SQL querying capability. So again, they're a very specific flavor of SQL or they're SQL-like. But basically you run some queries and it looks like SQL. It reads close enough to SQL. You have a few open source options on here, things like ClickHouse and Apache Cassandra. And there are a few others that just didn't fit on this slide, like Apache Druid, Apache Pinot, and I think a few others. Sorry, like I said, there's like 30 of them in total. And then you have things like Amazon Redshift and Google BigQuery, which would be the 2 big ones that you would know if you're in those ecosystems. Vertica is something that's owned by OpenText, very close source. And Snowflake is very special in that it is not only an OLAP, but it's also an OLTP. And I actually haven't defined that yet, but basically OLAP just means an online analytical workload database. So basically it's a database that's good for doing analytic workloads. It tends to be a columnar DB, just for reference. Like almost every single OLAP DB tends to be columnar, which is exactly what it's summarized here. You have your row database and you have your column database. Your row databases are good, like I said, for easier to add and delete data. For data modification, that's more complicated. You use something like Columnar. Again, ideal for OLAP situations. It's going to have a higher speed compression and require less space for data storage because in general, it's working with a higher data load. Again, you're not going to see any benefits from switching between row and column if you're only working with like 400 pieces of data. 400 rows of data is nothing in the grand scheme of things, but that's not what most people are working with. Most people at a company at scale are going to be working with things in the millions or billions or even trillions. And don't forget, it's not just like one data set. Half the time you have to combine multiple data sets. You take that phone information, go ahead and extrapolate it out to location of where these phones are being sold. Now imagine you're T-Mobile and you're selling phones in many, many countries, every single country in the world pretty much, and you need information about how much they're sold. You also have currency now. All of these data sets have to be conjoined to run this kind of analysis. And as you can see here, there's a bunch of words that basically go in and explain the exact same stuff I've already mentioned. You got your real-time data analytics. That's the other thing too, is if you want these queries to be fast, real time, you need to have something that, again, is not reading every single row as it goes through. It needs to be column-based. So what is Apache Arrow and Apache Parquet? So this is straight up from their websites, by the way. This is the quotes of the Apache website as to how they describe themselves. So Apache Arrow is a framework for defining in-memory column data that every processing engine can use. Great. Apache Parquet is an open source column-oriented data file format designed for efficient data storage and retrieval. And this is what I meant when I said Apache Cassandra is a little bit on the older side, is that I think nowadays it can take advantage of these, but it was built before these projects, from what I understand, or around the same time. Basically, it didn't get to take as much advantage, you could say. So the big benefits of things like Parquet files. So Parquet is a pretty common file format at this point for Columnar data store. You'll see it available on any of the major cloud providers. Honestly, any Columnar database project worth its salt is going to have Parquet file format capabilities, if not actually store your files in Parquet under the hood. Basically, it's used for that analytics OLAP use case, typically in conjunction sometimes with OLTP databases, but even better with OLAP databases. Basically, it means that you've got your traditional row-based databases that can take advantage of it, but it's even better if you use the DB that's actually built for it. It's very good at retrieval and deserialization of large amounts of Columnar data. And I'm actually just going to show this slide, which will kind of show it even better. So for example, here's data stored as a CSV file, then data stored on the Apache Parquet format. And this is within Amazon S3. As you can see, the size is significantly smaller, the query runtime is significantly faster, and the data scanned is significantly less. And I do not know how they got the cost to be exactly 1 cent, but I really appreciate that on this slide. And the big thing that this does is it basically does something called skipping. So everyone who's ever, had to do a FizzBuzz or had to do, one of those exams in coding, you know about the algorithms that basically say something like, I want to know the sale of phones between these 2 days. So what does it do? It's very smart. It goes, oh, they only want, this five days in the middle of October. I'm going to not look at anything that's older than that or newer than that. And I'm just going to check my 5-day chunk. That is exactly what Parquet allows the databases to do. It doesn't do it itself. It's just a file format. It's not magical, but it allows you to do that with it. So basically, a database like ClickHouse does this. They call it like merge tree. They basically allow you to be able to skip over these records, saving yourself a lot of time and a lot less data scanning. So that's part of how it ends up having this faster query runtime and this faster data scan, is because it allows you to do that. So the benefits of Apache Arrow. So Apache Arrow is kind of 2 things kind of wrapped up into one. It's like an in-columnar data store, yes, but it also allows you to basically transfer data between different projects. So it's language agnostic, so it's not like specific to any language, and it actually supports a wide range of programming languages, including things like C++, Java, Python, and R. And it's specifically built to be efficient for running on modern CPU and GPU architectures. If you want to find out more about that, you can go on the website. I don't really want to get into it here. But basically, back in the day, you would have something like this. You'd have your Apache Spark, your Cassandra database, your Pandas, and you would need to copy and convert all your data over between all of these different tools. And this is pretty normal, by the way. Most people tend to have to work with a lot of different tooling. It's not uncommon, to say the least. But now, with Apache Arrow, you no longer have to serialize and deserialize to send your data between all of these projects. And by the way, this is just the amount of logos that can fit on this. There are a ton more projects taking advantage of this than that are listed here. I think actually almost all of them are listed on the Apache Arrow website, but the screenshot for that would be way too messy. But basically, you can now go between all of these and be able to communicate, in particular, your Parquet files, but other, not just Parquet files, but just your file types in general. And this is also how people build out what they say is their client libraries as well, which basically means that you'll have something that's written in Python that allows somebody to query from your database into Pandas or query from your database into another DB. And yeah, that's basically how it works. It's basically just a much more efficient file transfer system. Like it says right here. Perfect. I'm going over my slides before I even get to them. But yeah, basically there's no more serialization or deserialization costs, so it's significantly faster. For example, this is using Pandas, and this is just doing Pandas where you are just doing it with a CSV file. And then this is one where it's taking advantage of Arrow, which is the Python version of Arrow. And basically with this, you can see it is significantly faster. It's also taking less time on the CPU. And just in general, it's much faster to basically read this file because you're taking advantage of Arrow. Something else I can't ignore to mention is Apache Data Fusion. So this is a project that is basically an extensible query engine written in Rust that uses Apache Arrow as its in-memory format. So basically what that means is it's actually taking advantage of Arrow as truly like an under-the-hood format, because this basically aims to be the query engine of choice for new, fast, data-centric systems such as databases, data frame libraries, and just in general applications leveraging the unique features of Rust and Apache Arrow. for all intents and purposes, this is basically powering some of the newer Columnar DBs that we're seeing coming out, and some of the offshoots of things like Parade DB, which is like Postgres SQL for search and analytics. So again, this is like a flavor of Postgres SQL that's being used for search and analytics because it's basically trying to be a little bit more OLAP. InfluxDB, my previous company, they built on top of Apache Data Fusion, and the creator of Apache Data Fusion is actually working at Influx, so they're very much very invested in the project. But yeah, this is just some of the people who are taking advantage of it. So let's go into a few more tools here. So I mentioned originally in the document that are in the abstract for this talk that I was going to mention Pandas, but as I was doing some extra research, I realized that nowadays a lot of more modern OLAP DBs actually kind of do a lot of, I guess you could say their flavors of SQL come with so much analytic workload capabilities in them. And this isn't just ClickHouse. This is also things like DuckDB as well like to talk about this. Basically, they even wrote a blog claiming that they killed pandas. I don't believe that, but you know, basically, you actually don't have to use it as much with some of the more modern OLAP DBs in Columnar databases because they're building out, same with actually Apache Data Fusion. Basically, every single time they release new features and such, a lot of those features are things that you will find in Pandas. But that doesn't mean it's not valuable. But one thing that I just showed here was basically just taking advantage of it with something like a data frame, which without a doubt is the most like common thing you're going to ever do. And it's why I showed it before for, you know, showing off how fast Apache Arrow is. But it's just something to keep in mind is that it's no longer necessary for things like data transfer now that we have things like Apache Arrow, which it definitely used to be used for. And even now for some of the analytic workloads, it's not nearly as relevant if you can just query with giant analytical, you know, SQL queries that'll basically give you everything like the average, the first and last, etc. You won't have to take advantage of it. Now, one thing I did want to mention, though, is CHDB, which is basically a SQL OLAP engine. It is powered by ClickHouse in the fact that they bought it about a year ago, but before then, it was completely built from the ground up by their own engineering team. They now work at ClickHouse, very nice people. But basically, they minimize data copy from C++ to Python with Python memory view. And this is just the docs here. That's what the QR code is on the side. But one thing I did want to show off as well is that specifically, this is an article that goes over this, they make querying with Pandas data frames with CHDB about 87 times faster than if you were just to do it basically in a plain data frame. And part of that is they are taking advantage of PyArrow as they do that. So this is just one example of a great tool to take advantage of. Another one is Telegraph. So Telegraph is an agent for collecting, processing, aggregating, and writing metrics, logs, and other arbitrary data. It's mostly metrics and logs. But basically, this is great in that it connects to most of the big Columnar databases as an output format. It's got about 300 plugins, 300 input plugins, I think about 25 to 30 output plugins, and most of your big OLAP Columnar databases are going to be available as an output plugin. It's a very low-code solution that basically allows you to pull data from various sources where you would get things like logs and metrics and go ahead and port them into your database. So for example, there's 300 of them, so I'm not going to have them all on the slide deck, but this is just some of the categories of Telegraph plugins that you would have available to you. So things like MQTT, a lot of these are heavily, like you could say they're in the industrial IoT space. When it comes to databases, that's like watching your database statistics, like getting the logs off of them. Things like containers, obviously, being able to check your Kubernetes information, networking, cloud, logging, gaming and entertainment, including, as I like to say, the less professional versions here, which is things like CSGO, for example. But yeah, basically, this is just some of the Telegraph plugins that you can take advantage of. And now let's go into some customer use cases. So in general, Columnar and OLAP databases are good for real-time analytics, logs, events, and traces, which is basically the Open Telemetry project, business intelligence, machine learning and generative AI, which I'm not going to go into quite as much here, and any application where you basically require a real-time data warehouse, which in this case, what that means is basically real-time as in you can get your queries back in less than a minute, ideally less than 30 seconds. So for example, Disney Plus, which I'm actually not sure if Disney Plus is available here in Greece. I hope it is for you guys. But basically in the US, it's very popular. It has, well, it's It's actually probably more popular for all the Star Wars shows than anything else. But basically, they have hundreds of terabytes of user logs and metrics. Whenever you're on the site, whenever you're watching something, whenever your family's enjoying movie night, they are storing all of that data because they're making sure that things are running as they expect. They're also, in general, definitely, some of those metrics are also definitely metrics about you and how much you're watching and what they can recommend to you, et cetera. But basically, with something like ClickHouse, they can read about 2 billion rows per second, so they can make sure the health of their system is good. They can also just make sure that, things are operating as they want. And again, they can recommend you things and just in general be good about their system. Again, you want to have a good experience. In general, Disney is pretty big about this. They want to give you a good experience, whether you're watching Disney Plus or at one of their, theme parks, etc. So this one's for real-time analytics. So Cloudflare specifically migrated from PostgreSQL, which again, that does not mean they migrated their entire workload off Postgres. I'm sure they're still using it for the key, transactional capabilities it's great for. But basically, ClickHouse can ingest about 8 million rows per second for them. It had a 7 times improvement on query throughput, and it reduced their mean time to repair, which basically means the mean time to, fix something that's going wrong because you actually know it's going wrong right now versus, 5 minutes later, et cetera. Significantly down, which is good because this is what they were using for their customer dashboards. So this is their customers taking advantage of Cloudflare's offerings. They have dashboards where they can see their, their use case, et cetera. And now they're going to be able to take better care of their own capabilities. This is, this is very important if you're a company that has to answer to basically other businesses and you host their stuff. So this one is a pretty straightforward one. This is a use case of observability. So they manage, so DD is, they migrated over from Elasticsearch, which again was what I mentioned at the beginning. It's a logging database, so it's very common to put logs in something like Elasticsearch. But with this one, they had about 15 million queries per day on their logs, which is pretty impressive, I'm not going to lie. And they had about a petabyte of the logs per day as well. So they were being really, so Elastic actually was doing pretty good at the querying. That's not the problem that they had. The problem they had was storage. The compression rate just wasn't ideal for the amount of data that they're dealing with, which is something I didn't really mention in my talk, but it does become a problem at scale. You need to be able to compress this data. You got petabytes of data a day. You're going to be paying quite a bit of money for that, and being able to have a database with a better compression rate is certainly worthwhile. And then finally, a data warehouse. So they're using us basically as a central data warehouse. It's the analytics for their website and their apps, their company metrics, and their monitoring. So again, this is what I mentioned before when I said that you don't normally just have one data set. It's not just one data set you're running analysis on. It's normally multiple data sets from multiple different pieces within the business that will basically help you, deal with business logic, et cetera. And then these are just some final resources. So this is obviously resources for ClickHouse. Again, though, if you want to find out more about Columnar databases and just in general, you saw one that, struck your fancy, I guess you could say, you could literally just look up Columnar DB on Google and you would find all 30 of them. But basically here, you can also find things like our Slack community where you can get help from someone like me, or you can find me there. You have docs, we have certifications, et cetera. And speaking of that, when it comes to certifications, tomorrow I'm actually running a workshop called ClickHouse Fundamentals. It's very obvious what the workshop's going to be about, but basically we're going to be going over how you take advantage of ClickHouse, how you use it, and if you do it, you get a little badge, which unfortunately I think I deleted the badge slide, but basically it's going to go over different pieces that you see here, things like inserting data, I don't think we're going to get into deleting, but managing data, materialized views, et cetera. And I just wanted to show off that you can also do it on your own. If you don't want to come to my workshop or, you're not coming tomorrow, you can just in general take advantage of this. It's totally free. And that is currently the end of my presentation. I'm not sure on time what we got, if we have some time for Q&A or not.
I'm sure we have some questions. Oh, there's already a hand there. Right. You ready?
Yeah.
Yeah. Born ready.
Hello, thanks for the presentation. One very basic question about difference between row-based and columnar-based databases.
Yeah.
I do know that row-based databases has to do with the locality of the data in the disk. All the row is in the same page. We have an index. You find through the index which is the page. and then you load it, and there are also all the data of the specific row of the database. Let's say a schema like MySQL is working like this. I'd like to understand how is a Columnar database, the locality of the disk. We have 1 million rows in several places around the disk, and you are just running an aggregation query, and this is fast. How is this faster?
So basically, the way that it's fast is that the primary index for, as you just pointed out, a primary index for a row database is normally a unique identifier, like an ID, for example. But in a columnar database, it tends to be a little different. You think about how you want to query your data, like again, with the phone pricing model. You want to figure out the average phone price. So what you're going to set the primary index to is pricing. And that's going to make it a lot faster when it begins to do those queries. And that's why, again, it's going to do things like ignore query, like it's going to ignore rows that, for example, might be empty on price, et cetera. Or it's better actually when you do things like dates in particular, then it's better at like ignoring, things before and things after. But it's also just going to be a lot faster in the fact that it does not have to read every single individual row. It just grabs the price column, runs the giant aggregation on 4 million rows, and then spits back out your average. So basically, it's ignoring the other data. It's ignoring the Boolean that says whether it's unlocked. It's ignoring the description, and it's ignoring the ID column. It doesn't care. It does not care about any of those. It only cares about price, because that's what you're currently asking for. So that's how it's so much faster.
Attendees, questions?
Any more questions? Tumbleweed.
That's all good. And to be fair, it's pretty much basically lunchtime, so.
It's pretty much lunchtime.
It is pretty much lunchtime. I saw it in the schedule.